Hey, welcome everybody. Welcome to 3.1. Why are identical twins rare? Okay, I thought this was spider class, but apparently now we're talking about identical twins. Hey, whatever. I'm just going to go with it and just give me an A, right? No. Hey, first things first, congratulations on finishing chapter 2. We definitely want to make sure that we know some of those key points from chapters 1 and 2. One of them, namely, that traits are ultimately determined by the proteins that are made in the cells of the organism. So what determines which proteins get made? And that comes down to the genes that the organism has in the cells. The genes are the instructions for the proteins. And typically we find 2 copies of every gene. Sometimes those copies are the same, and we would say that that organism is homozygous for that gene. Sometimes the genes are different to different genes, and we would say that the organism is heterozygous. Okay, so just a quick little recap there. Let's jump to the warm-up, and we are going to look at a picture of sisters. Here we go. Oh yeah, remember them? Hey, the last time you saw the sisters pictured above, you considered how different protein molecules in their cells could lead to different traits. Now you know that genes provide instructions for proteins that lead to traits. How could these sisters have ended up with different genes, leading to their different proteins and traits? Just like some of you might have a brother or sister, and you have the same biological parents. Well, how did that happen? How did it come about that you don't look exactly like your brother or your sister, unless you actually are an identical twin? I've had plenty of those come through my classes. But we're focusing on these two. How could these sisters have ended up with different genes leading to their different proteins and traits? Explain your ideas below. Hey, go ahead, do that, think about that, and come back to me. All right, let's go ahead and now jump to activity 2, which is introducing the chapter 3 question. And let's review this really quick. Remember, why is this spider class? Oh yeah, we're helping the Bay Medical Company determine how to breed spiders that will produce offspring with the trait for medium silk flexibility, so that every single little spider baby always gets the medium silk flexibility. And here's the family tree that we were looking at. We have daddy spider, we have mommy spider, we know their traits, and then we have all the offspring. But we also know for the offspring, the proteins that they make. We don't just know the traits, we know their proteins as well. In order to help the researchers, we need to determine why the Darwin's bark spider's offspring have different traits for silk flexibility. Why do they have these different proteins? Why do they have these different genes? That's what we're going to look at. Where do we get our genes? Most of us probably know from our parents. But how does that work? How come they're different? Why are they different? I want to know. So we know the silk flexibility gene versions. Look at this. In our last model that we made, we not guessed. It's that fancy word for guessing. Yeah. Anyway, we tried to come up with our best guess for which gene versions each of these spiders had based on the proteins that they made in their cells. Okay. I skipped. So what do you notice when you compare the new data about the offspring's gene versions to the predictions, to the predictions you made in your models? Remember this variation spider offspring model where you had to write in their gene versions, and now we know the gene versions of the spider offspring. Were you right? Were you wrong? What? If you were right, nice job. I hope that was intentional. If you were wrong, well, where did we go wrong? What did we miss? Here's our chapter 3 question. Why do the Darwin's bark spider offspring have different gene combinations even though they have the same parents? This is related to our warm-up question, isn't it? Looking at those sisters. Why did those sisters have those 2 different gene versions? We have rewritten our claims, okay? The first claim that tries to answer that question says, the offspring have mutations that affect their traits. Now that one's the same. The offsprings have mutations that affect their traits. Is that what we think happened? That every time little spider babies are made that they have mutated genes? Claim number 2 says the offspring's traits depend on which parent the offspring received more copies of genes from. Ooh, copies of genes. That part has been rewritten. And claim 3, the offspring receive different combinations of gene versions from their parents. What I want you to do is I want you to think about all of these. And I want you to think, hey, which one do you feel right now makes the most sense? Based on what we know, based on what we've seen, which of those claims makes the most sense? Ms. Reagan, I don't understand them. Take some time. Take some time. Look at them. Read them over. And once you do that, I'll probably ask you in class when we meet again, what else do you need to know to support one of these claims? Maybe you just have a gut feeling like, no, I really think it's this one. Well, okay, so what evidence do you need? What would be the final thing that really helps you to argue for that claim? And think about that. Once you do, come on back to me. Next, hey, now we are going to read why are identical twins rare. Let's go find it. And oh, look, activity number 3, why are identical twins rare? Okay, here it is right here. Oh, no, there it is right there. It should show up actually down here somewhere. Maybe not. You can click on the link and it'll take you there. Hey, I want you to annotate, please. I want you to please annotate the article. Whenever you find any kind of words that are unfamiliar, highlight them, go look them up. A lot of times they'll already be highlighted in the article and you can click on them and get the definitions right there. Any questions that you have, I want you to write down. Anything that is confusing, go ahead and write down, or anything that you feel like, hey, this is a really key point. This helps me understand. Highlight that, underline that, and make a note next to it. This is the question. This is the question that we're really trying to answer and focus on as we go through the article. How do organisms get their genes? How do organisms get their genes? How did these twins get their genes? Once you do that, and please add your annotations, come on back to me. Activity 4, discussing annotations. We'll do that in class when we meet together. Yeah, I'll ask you about the article and what you thought about it and what questions you had, things you found most interesting. Let's just jump to some vocabulary really quick, though. The first, oh, geez, are we allowed to say this in class? I don't think I handed out permission slips. Sexual reproduction. Hey, it's okay. It's okay. It's not what you're thinking. When we're talking about sexual reproduction in our class, what we're talking about is when an organism gets its genes from 2 parents. That's sexual reproduction. That's what it's talking about. The process in which 2 parents pass on their genes to create offspring. Well, what's the other type? Asexual reproduction, right? And that's 1 parent. Something like a bacteria would go through asexual reproduction, where it just makes an exact copy of itself, okay? A lot of single-celled organisms do that. Sexual reproduction, though, you're getting genetic information from 2 parents. 2 parents. Let's look at this next word, inherit. When we're talking about inheritance in our class, we are talking about receiving genes from a parent. You probably have heard the word inherit before, or inheritance. And a lot of times when people use that in today's language or conversations, it's something that you get from someone else. Usually when they pass away, you might get an inheritance. But in our class, it doesn't have to mean that somebody passed away. It's just the genes that you get from a parent. All right. Review your annotations, answer the reflection questions. Hey, did it help for you? And then, let's talk about our homework. For homework, you're going to meet spiders in the sim to learn more about inheritance. To do this, a lot of people have already asked me how to do this, and a lot of people have already played with this and they figured out how to do it. You'll drag a female spider over a male spider. So when you click on one, you saw those circles. It shows you, okay, these are your options. You can drag a female spider over a male spider. Then you'll press create reproductive cells. Okay. Once you do that, hey, look, you have the reproductive cells. These are all the, is that the male over here? The male reproductive cells, the female reproductive cells. And then you're going to press random fertilization right down here. So all of these arrows right here on the bottom. That's what we're choosing. Choose a feature to focus on and compare the offspring with each other and with their parents. Hey, you could use silk flexibility. We've already been looking at that feature. You're going to create some random offspring. Compare that feature with each other and with the parents. Also, what you're going to be doing for homework, you're going to be reading an article about cicada reproduction. Really interesting. Really, really interesting. Maybe you've heard of cicadas before. This is them right there, that insect, and all these spiders are going, oh, that looks like a good tasty dinner. We could eat that thing for weeks and bring it home to all our little spider babies. And that's probably not like scale. But anyways, you're going to read about cicadas. Do you have some questions? I don't remember if you have questions, but look for them. Make sure if you have any questions after the cicada article that you answer those. And hey, after that, you're done. Congratulations.